Swayam Prabha. Digital India. Educated India.
Welcome back. So today we are going to start a new topic. This is on landslide and related hazards. Briefly, we had some discussion in the initial lectures where we talk about the landslides and which are the main locations where we can expect the landslide and what are the reasons for that. Very briefly we discussed, but now we are going to discuss in detail about the landslide. Now this photograph was taken after the 2015 Gorkha earthquake in Nepal, where the landslide was triggered because of strong ground shaking. Now in this topic we are going to also talk about the different type of landslides, or we can say in total mass movement. This is another photograph from the similar reason for the landslide. So landslide, or we can say mass wasting. So mainly what we see is the first photograph, if you recall, it clearly shows the downward movement of the material which is sitting on the slope. So there are few parameters which will be essential to trigger the landslide. As one is the slope and the material, the type of material which is resting on the slope. So if the slope is higher or steeper, then the chances of having landslide is greater. But again, it will depend on the material, what type of material is available. If it is a loose material, then the area will be prone to landslide without adding much of the sort of what I would say that ingredients like water, if you have, because if you, as soon as you make the slope material saturated, it will lose the shear strength, and it is most likely that it will trigger the landslip or mass wasting. So let us see what this means is the downward movement of slope material due to gravity. Material may comprise rock fragments, soil, or artificial fill along a defined or prominent boundary or plane. So the movement will occur along a defined plane. Movement may be in form of falling. So this falling will be very typically seen if you are having a rock strata. Sliding also can occur if you are having a rock strata, but we need to have either the rock strata or the succession is having joints. If they are jointed, then they can slip along the joints. So movement can occur along these joints or the bedding planes, we can say. So joints will be either vertical, but that again will be very important because that will affect the shear strength of the material. So either we say fractures or the joints in the succession, or it may be in form of flow, or with the combination of all three also. So if you are having a fall, then most of the areas where we are having in rock blocks which are sitting loose, then we may have fall, we may have slide, as I told. If you are having even the bedding plane, or the material is fractured, or jointed. And flow itself, it talks about that it will have a very loose material. Plus, we can say that they are saturated. So, mass fasting or the mass movement mainly occur on slope. So, this is a very important parameter which you will have to take into consideration. May be influenced by natural processes or human activities. So, natural processes could be your water. If you are having a very high pouring down of rain, then you may have the issues with the material sitting on the slope. If you are doing like a lot of material has been poured or been put on the slope, that is an overburden, then also that will trigger the landslip. Or you are doing a down cutting. So, suppose you are having a slope like this, and if you remove the material from below, then this material can slip. So, there are few things which are very common, and I would say the trivial, but they are very much important when it comes to the mass movement. So, what controls landslide? This is the part. The movement depends on balance of forces acting on slope. So, as we were talking about, that movement will occur under gravity. So, these are forces which will be acting on slope. So, one is your driving force, which will always tries to move or pull the material down slope. So, if you are having the slope here, so whatever the material is sitting on the slope, you will have one force acting here, and then another one is the resisting force, which will try to hold the material which is sitting on the slope. So, one is this will be your driving force, and another will be the normal stress, we can say, that we will discuss in the next slide, that will keep the material and doesn't allow the material to move down slope. So, that is your resisting force. So, driving and resisting forces, driving forces can be increased. One, if you increase the slope angle. Second, you increase the amount of material on slope, that is loading or overburden, either by natural process or by human activity. So, we should understand that if you are having the slope could be an unstable slope, you cannot keep on putting load or dumping the material on that. This overload or overburden could be also the civil structures. Then by turbulent currents in river channels, which will lead to tremendous erosion on the side banks along the bends. So, you have the suppose you are having the sinus channel or meandering channel, then this portion will keep on eroding. So, if you are having a section like this, suppose, and the river is flowing, if it keeps on eroding this, I am putting the section. So, if it keeps on eroding this part, then this may collapse or it may result into the landslide. Then decrease resisting force can be because of saturating the slope material by water. So, in most of the areas, what has been done is that to allow the water flow as early as possible, or flow out of the water should run off as early as possible, then they try to construct the small waterways or the canals as so that can be drained out as early as possible. And if you allow the water to percolate down, then you may result the material getting oversaturated, which will result into decrease in resisting forces. Then another one is shaking of the slope material during an earthquake. So if you have a loose material sitting on the slope, and if there is an earthquake and major ground shaking is there, seismic shaking, that may result into the landslide. And that example we have seen in the first slide, which was from 2015 Gorkha earthquake. So causes of landslide, the main factor that influence the slope stability is gravity and is responsible for most of the mass movement. On a flat surface, the force of gravity acts downward, that is your normal stress. So if you are having a very flat surface, whatever the material you have, you don't have any driving force over here. So the material will remain in stable condition. It will not move because this is very strong here. So in this case, the G is equal to Gp, whereas the Gt is almost 0, that is your shear stress or the driving force is almost 0 here. So it will not allow the material to move. So as long as the material remains on a flat surface, it will not move under the force of gravity. On a slope, the force of gravity can be resolved in two components. So one is your Gt and another one is your Gp. So a component acting perpendicular to the slope, this one, is your normal stress. So what we were looking at here, the G is equal to Gp. So that is your normal stress, and another one is your shear stress, which is acting tangentially to the slope. So this is your driving force. So if this becomes greater, then you are allowing the material to slip or slide. So if Gt becomes greater, that is your shear stress, then Gp will reduce. So if Gt is greater than Gp, then you are preparing or creating an ideal condition for the landslide. This is also termed as angle of repose. So here in this case, Gp is almost equal to Gt. Of course, here it has been shown that with an arrow which is smaller, but if there is no slip is occurring here, then in that situation you will have Gp, which is your normal stress, will equal to Gt, your shear stress. But in case here, what you have done is, the situation is that you have the Gt, that is your shear stress, is greater than normal stress. And what difference you can see here is the material, the mass which is sitting on the slope of failure is same, but the angle has increased. So if you are having greater angle, then with the same land mass, the Gt will increase. So, your shear stress, that is the driving force, has increased, which will result into the loss of shear strength of the material and eventually result into a landslide. So, force of gravity can be resolved into two components, that what we have discussed. So, one is normal stress and shear stress. So, this diagram also explains the same. This part will come later when we are talking about the factor of safety, where we talk about the coefficient of friction and all that, and then normal stress also. And then if you are having a water saturated material, then we will have an effective normal stress. So, stress, when a force is applied to a solid body, stress is or forces per unit area, because we usually take a stress as a point where the force we are applying per unit area are transmitted within the material. And if you take the gravity imposes a shear stress, that is your tau, on all the slopes. So, tau is been given as W, where W sine beta, or you can say it is W sine theta, that is an angle of slope, and this will be your shear stress. So, where W you take is your weight of the slope, that is the material which is sitting on the slope and along the or above the potential sliding plane. So, beta is your slope angle, gamma is your unit weight, and Z is your depth. So, if you have all this information, you can easily talk about the factor of safety. So, where you have the material which has been given as normal stress, and you take into consideration the weight and depth here. Now, role of gravity on landslide. Gravity acts as a weight per unit area of slope material, producing a vertical stress, say V, and we have this as a normal stress, and this one is your shear stress, and beta is the angle of shear plane along which the material can slip, and that is your also we will say angle of friction. So, the vertical stress V can be resolved into two components acting at right angle to each other, that is your GT shear stress and GP normal stress. The relative size of GP and GT depends on the slope. This is what we just discussed in the previous slide. So, this will depend on the slope angle, because as soon as you vary this two components, that is the GT shear stress and the normal stress GP will vary. So, suppose you take randomly that beta is equal to 20. So, what is the so here the situation is that GP is greater than GT. So, your resisting force is greater than the driving force here. Now, again we increase the slope by about 20 degrees. So, the vertical stress, again we are having the two components GP and GT. So, here also we have GP is equal to GT. Further, if you increase the slope say 60 degrees, then you are reducing the GP and you are increasing the, so you have increased the shear stress, you have reduced the normal stress here. Now in this condition you will have a landslide. So eventually GT is larger enough or large enough to produce slope failure. So this we have in, this is the result of the increase in slope. So water within slope will eventually complicates the simple picture what we are trying to understand. So it is not only the slope, of course the slope is important, but not only the slope will play a crucial role, but if you have water saturated material, then this will complicate the whole scenario. So water content and normal stress, if you take, then we have the GP here, and if we are having the sigma, that is your pore water pressure. Now the pore water pressure will have some sort of an buoyancy effect, and that will result into your what has been produced is smaller effective normal stress. So sigma prime will be your GP, what is a normal stress, minus the buoyancy what you are going to do. So that will again, even if you are having a very gentle slope, or maybe say around 20 degree or 40 degrees, where in the previous case it was not moving, but as soon as you have the water in it, water content, that will have the effect of buoyancy, resulting into the effective stress or effective normal stress, which will be lesser than the GT and result into the slope failure. So if you are having the material, type of material which is porous, can hold the water very easily or get saturated, that can be dangerous. So shear strength of slope material is the most important characteristic in terms of resisting shear stress, and is related to cohesion, because sand is cohesionless. Okay. So it will depend on the cohesion, it is related to cohesion, and the normal or the effective stress will also get affected. Now if we take shear strength of the material, that can be resolved as C plus sigma 10 phi. 10 phi is your internal friction of coefficient, and she is your actual cohesion. So as I was talking, that if you are having sand will have is cohesionless, so the internal friction of coefficient or angle of internal friction will be different than the other material, like if you are having silt or clay. Then comes to the shear stress. We have already discussed about this, that is tau, and is given as W sin beta, where W is the mass of the material, that is the weight of the material on the slope, and beta is your angle of slope here. Now coming to this equation, Coulomb-Tarasaki equation is usually been taken into consideration when we are talking about the shear strength. So where SH is the total shear strength, either you say tau, C is the cohesion, normal stress, and T phi is your coefficient of internal friction. And the shear strength of the material on slope, if you take, suppose you are having the shear stress and shear strength, then mass of the material need to be taken into consideration, slope angle, shear stress, that is your W sin theta, where the W is your mass and gravity here, Newton per kg. Now, if the weight is say around 500 kg and your theta is around 30 degrees, then you have W is equal to your 500 kg into 9.8 Newton per kilogram. So, this will give you 4,900 Newton of weight or the force, and the shear stress will be, we have to take this one here. So, shear stress will be your 4,900 into sin 30. So, finally, the shear stress of the material which is sitting on the slope will be 2,450 Newton, and the cohesion, if we take above for the shear strength cohesion, we need to take internal friction of coefficient. So, you have the shear strength, which we were talking about the Coulomb-Tarasag equation. So, where C is the strength, normal stress, and phi you are taking the coefficient of internal friction. So, we will stop here and we will continue in the next lecture. Thank you so much.